All right, for example 2, things look a little different. My p of x is actually a bigger degree than my q of x, and we know that that was a no-no. However, I still can't do a u substitution because this degree is too big to get this one. There's no way I can do Lipit, so I have to do partial fractions here. So what happens when the degree on the top is bigger than the bottom is we actually have to do long division. And I know it's been a while for some of you, so this one does not work with synthetic because this is a quadratic. So what we do know is this one has 2 linear factors, x plus 1 and x minus 1. So that gives us a little bit of hope here. All right, but we have to do long division. So when we do long division, you put the bottom on the outside, and then we put the top on the inside. The problem is we have to fill in all those space holders with zeros. So we have to say, all right, 3x to the 4th, 0x cubed, 0x squared, 0x plus 1. All right, when we do long division, you only look at the first 2 terms. And I'm going to do what is 3x to the 4th, and I'll do that work over here, 3x to the 4th divided by x squared. So I can see these are going to cancel out. I'm going to be left with 3x squared. So I'm going to put that over the x squared term, so 3x squared. Step 2 is to now multiply this by everything over here. I have to do it times both parts. So 3x squared times x squared is 3x to the 4th, which is what we were hoping. We want to get rid of that. And then 3x squared times negative 1 is negative 3x squared. Notice I'm lining up my like terms. Now I have to subtract these. So these cancel out. 0 minus nothing is just 0. But here we get 0 minus negative 3x squared. That's a positive 3x squared. And I'm going to go ahead and bring all of my other terms down. And now we start the problem over again. We have a new division problem. First term and first term. So 3x squared divided by x squared. So we end up just getting 3. And we do the same thing, multiply through both problems. So 3 times x squared is 3x squared. And then 3 times negative 1 is negative 3. Subtract. 1 minus negative 3 is 4. So what we've got now is our result of 3x squared plus 3, and we don't write R4 like we did in elementary school. What we do say is our remainder is 4 divided by x squared minus 1. So we still have this weird fraction in here. So all we did is rewrite this problem. So we still have this as our integral. Now integrating this part and this part, no problem, we've got that. This part we have a little bit of a problem with. Now I've got a p of x that's smaller than my q of x. So for this part, we now get to do partial fractions. Did you hear that I said we get to? Yay! So I'm going to do some side work again up here. So I've got 4 over x squared minus 1. And I've got my 2 fractions. So I've got my x plus 1 and my x minus 1. So again, my domain restrictions, I can't have plus or minus 1. So I'm going to go ahead and write my equation. Cross multiply. So a times x minus 1 and b times x plus 1. And we want that to equal the top. So that's kind of nice. We don't have to plug into anything over here on the right. And now I check those domain restrictions. So I'm going to check x equals 1 first. So I get a 0 here. 1 plus 1 is 2. 2b equals 4, so b equals 2. And then I want to check x equals -1. So if I plug in -1, I get -2a. Here I get 0. So here we get a equals -2. All right, so here this one is -2, this one is +2. I'm going to tell you when we rewrite my integral, if you ever have a -1, always put it second. So we're going to switch the order of these, and I'll show you what I mean in just a second. So now let's rewrite this entire integral. So we had 3x squared plus 3, and then we fixed this one up here. I'm going to put the positive one first, so 2 over x minus 1. And then my -1 second, so minus 2 over x plus 1 dx. Now I can integrate this. So the antiderivative of 3x squared is x cubed. Antiderivative of 3 is 3x. Antiderivative of 2 over x minus 1 is 2 natural log of x minus 1 minus 2 natural log of x plus 1 plus c. Now I'll tell you on a multiple choice question, that would not be one of the answer choices. I'll rewrite this first part. But this part, they would expect you to use logarithm rules. And if you remember, if there's a number out front, that's the same thing as an exponent here. So it would be a squared and a squared. And when I subtract 2 natural logs, it's the same thing as dividing these two inside pieces. So what we would end up with here, and this is why I wanted to put the -1 second, is you would get natural log. This one goes on top, x minus 1 and x plus 1. Now I can square them both individually, or I can square them because they're both squared. I can just put the squared out front. Because it's squared, I don't need the absolute value in there, but just to be safe, you can go ahead and just put them in there, and then, oops, plus c.